All right, now for the fun stuff. All right, advanced JavaScript. So primitives versus objects. So we talked about primitives before, but we didn't really dive into what they actually meant. So primitives are all immutable. That means their value cannot be changed after they've been set. You can, of course, reset a variable pointing to a primitive to a new primitive, but it doesn't actually change the primitive that was declared at the beginning. But objects are mutable and are stored by reference. So everything other than a primitive is an object. That includes arrays, objects, functions, any other classes that you may create. They're all mutable, which means they can be changed after they've been created, which is why we can just declare an empty object and start adding to it. And everything that stores an object stores it by reference. And so what does that mean, passing by reference versus passing by value? We talked about it in CS50. Does anybody remember what it means? Anyone? Yeah. Yeah, so it's kind of like a pointer. So that's exactly what it is. So passing by value means you create a new instance of that value and you pass it to a function. Whereas with reference, you actually pass a pointer or reference to the original object or whatever variable, and you're free within that function to modify or change that object. And so let's take a look at some examples of this. So say we are going to create a new, let's talk about primitives first. So say we do var int 1 gets 42, var int 2 gets int 1, int 2 is now equal to 50. So then if we're going to console.log, so what do you think is going to print out here? So we create a variable called int1, give it 42, say int2 is equal to int1, and then reset int2. And so what do you think is going to happen when you print out int1 and int2? Right, so we know that primitives are immutable, so if we run this, you're correct. So int1 is 42, int2 is 50. So now, if we remember, objects are all passed by reference. Let's see what happens when we use objects instead. So var object1 gets, let's call it empty object. Var object2 is equal to object1. And then now let's do object2. This. So what do you think is going to happen if we then console log object1? So ignore that JSON.stringify thing for now. It essentially turns an object into a string. But what happens if we create an empty object, object1, do object2 equals object1, and then set a property of object2? Yeah? It'll print test, right? Why does that happen?
Because when you set object2 equal to object1, object2 is just a pointer to object1. So when you change object2's test, then it'll point back to object1.
Yeah, exactly. So just like in C when we said like object2 is equal to exactly where object1 is pointing, they're now referencing the same exact object in memory. And so when we do object2.test, it sets the property on that object in memory, and object1 and object2 are both referencing that object. So if we were to print this out, I spelled stringify wrong. It now says test. So you're absolutely correct there. And so what happens if we start to put objects or other arrays or something within those objects? What happens there? So say object2 dot array is an empty array. Say object2 is now an empty array, and we create this new variable and set that equal to object2.array. And then say push onto that array. So what did we just do? So we said object2.array. So we created a new property on object2, set it equal to an empty array, set a new variable equal to object2.array, and then pushed onto that new array. What did we do? Somebody talk me through that. I'm just going to stand here till somebody volunteers. Any guesses? Yeah.
You made an X a pointer to object2.array, and then you basically put a 1 in the array.
Yeah, so what happens if we now print out object1? So what is this going to print out? Is it going to have the array? Yes? Who thinks yes? Hands? Higher with confidence? There you go. Who thinks no? So let's find out. There it is. Nailed it. Good job. So everything that's not a primitive is an object, right? And so everything that's not a primitive, so that includes objects, arrays, functions, any other prototypes that you create, they're all stored by reference. And so when we do something like this, object2, when we create a new array, that is also an object, and so that's by reference. So when you do var x equals object2.array, that gets that reference to that array as well. And so it's the same array, which is also connected to object1 and object2. And so when we do x.push, that pushes to that array, and so it shows up on object1. So nailed it.
Is X a pointer to a pointer, or just a pointer to object?
Don't think of it as pointers anymore, just because pointers don't really exist in JavaScript. That's more of a low-level thing. But
Or are they both the same pointer?
they're both independently pointing to the object. So it's not a pointer to a pointer, it's a new pointer that has the same value. If we were talking about in C, but in JavaScript it's just referencing that same object. Nice. So this. Has anybody heard of this with the lowercase t? Yeah, some. So it's appears in a lot of object-oriented languages. JavaScript, of course, is not object-oriented per se. It uses the prototypical inheritance. So this functions slightly differently. But essentially, it refers to an object that's set at the creation of every single new execution context. What? And so it refers to the invoking object. So in the global execution context, it refers to a global object. If a function is called as a method of an object, then it points to that object that the method was called on. So what does that mean? Has anybody used the keyword this before? A few people? So let's do this one in the browser. So if I type this in the middle of nowhere, what will that write? So referencing the slide again. Yeah, so since we're in the global execution context, it's referring to the global object, just because every time so when we created the global execution context, that created a new execution context and therefore created this variable. And this references the object that it was invoked on. And so in the global execution context, the global object is the object that every single thing is invoked on. And so this therefore references that global object. So if we type this, then we get that window object. And we can say, hey, does this equal window true? Because they are the same thing. And so in Node, same thing. If we were to do this, then we have that function that we recognized before as that global function. We can do assert that this is global, and it is true. And so what happens when we then start to use this in other ways? So I'm going to do this in the browser for a reason. So essentially, it's a really confusing thing that I had a little bit of trouble with last night. But say we did this, so vim this.js, and did console log this. What should this print out? Yeah. So if we do node this, empty object. So I was sitting there last night, I'm like, what the heck is going on here? So if anybody else thought what I did, it would be that it should print out the global object. But Node actually, it creates each script as a modular script. And so each script runs within its own separate like execution context. And creates its global context to what it's eventually going to export. And so once we get into later parts of the class, we'll talk about like module and module.exports. But essentially, every script has its own properties and methods that it will eventually export, specifically Node scripts. And so since we didn't declare exports at all within this script, there's nothing attached to that exports. And when we console log it, it's just an empty object. That will probably never help you. I had never run into that in like the years that I've been doing this, but if you ever run across this error or not, unexpected behavior, now you know why. And so that's why I'm choosing to do it in here for now. But so if we did console.log this, we of course get that huge window object. But what if we did this function? What is this? And all that does is console log this. So what do you think will happen if we executed this function? So now, rather than just console logging this, we're invoking it from within a function. Any guesses?
Still global.
Still the global. Good call. Why?
Because it was declared in the function, it doesn't have like a method invocation.
Yeah. Pretty much. So remember when I was talking about the global object, and every single function that you declare and every variable that you declare just gets stuck on as properties and methods of that global object. So when we declared this function called what is this, it's now a method of that global object. And so when you run that function, then yes, it's exactly in the global scope. And so when you console log this, this is actually the object that it was invoked on, because when we do what is this and just declare it, it's now a method of that global object. And so it returns that global object. Does that make sense? Yeah.
So if you did the drop down like you did before,
Mhm.
you would find the function what is this, right?
Yep.
The method,
What is this right here? Yep. And of course, we can look at the prototype. The prototype here is a function. And so we can look at all of these methods that we have on the function prototype. And then that also has a prototype, which is the object. And so we can look at the object prototype, which has a bunch of methods that you can use on an object. That also has a prototype, though it doesn't actually write it. But the prototype of object is null. And so, yeah, that's just, you can look into the prototype down like that. And so how do we get this to be other things? So let's create a new person. I'm just doing this in a script so we can refer back. So we had function, what is this? That just console. And so that, if we invoked it, would print out the global object in Node as well. And so now let's create a new object. call to person and do first name, last name, and let's throw a method on it, call it greet, and it'll be an anonymous function that just returns hi. Ooh, keyword. So now we have an object with a couple properties, first and last name, and a method, which is an anonymous function that just console log this plus first name. And so actually let's also do what is this in here, which is so what happens if we run what? So we know what happens if we run what is this, right? It'll print out the global object. What happens if we then do person dot what is this? Yeah, I should print the person object, right? Because now we're calling this function as a method on the object, and so this should be bound to the method that it was called on, the object that the method was called on. So if we run this, then we have that function, or that object. And so now let's run greet. So what do we think greet will return? So greet is also a method on the object, right? And so this gets bound to the object it was invoked on from the method, so person. And so what is this dot first name? Jordan. So this should print out what? Yep. Cool. So there are also ways that you can set this manually. And so there are these three methods, functions, called bind, call, and apply. And these are actually all methods on every single function that you ever create. And so if we look over here at when we created what is this, if we look at the prototype of the function, we see apply, we see call, and we see bind. And so those are these three functions, and they're within the prototype of every object. And so these functions allow you to manually set what this is as a first argument in either one. And the difference between the three is bind will return a new function with this bound. Call will actually call the function with this bound and any arguments as well. And apply does the same exact thing as call, but it takes two arguments. The first is what this should be bound to, and the second is an array of arguments. So if you have like a variable number of array of arguments that you want to pass, you should use apply. Otherwise, you could use call. So let's use these and see how they work. So let's create a new person, call it student. And let's do first name is John, last name Doe. So if we wanted to do student, if we wanted to add a method to the student object, we could do that, right? We could do student dot greet gets person dot greet. And now if we run student dot greet, what do we expect to see? Hi Jordan, hi John, any other hi undefined maybe? So what did we effectively do before we run it? So when we did student.greet gets person.greet, we essentially said, hey, take that greet function, cut it out, or copy it, and then stick it in that student object like that. And so that's essentially what we did when we did student.greet gets person.greet. And so now when we run student.greet, what do we expect to see? hi John, right? And so we will hi John. But what if we didn't want to actually add a method to that student object? What if we just wanted to run the function from within person, that method, on the student object without actually adding new property to it? So that's where we then use one of those three functions that I mentioned. So bind will take, the first argument will be what you want to bind this to, and any further arguments will just get passed to the function whenever that function is invoked. And so if we wanted to call person.greet on student, we would do person.greet, which gets that function from line 9, and then .bind. So because greet is a function, it has a bunch of methods on it, including bind, call, and apply. And so we can just do greet.bind, because remember, functions are also objects, so you can access their methods with that dot notation. So greet.bind will return a new function, and we get to now choose whatever we want this to be. And so we want this to be what? Student, right? And that will be a new function. So student greet is now the function person.greet, but rather than this referring to person like it does on line 9, it will actually refer to student because we just manually set it there. And so now if we call that, it will say hi John. Is that confusing to anyone? Because it was confusing to me when I first learned it, yeah.
Is that wrapped up in the student object? Like, can you access it using the dot notation?
No, so that's actually so if we did student.greet without this line, that is not there. So if we were just to print out if we were just to console log the student, it only has first name and last name. It doesn't have an additional method set on it. But that function called student greet, that's actually a new variable that we called student greet that we set equal to a function that will just invoke the person.greet function method on the student object. And so we could invoke it immediately if we wanted to by just doing this. Meaning take that function and immediately invoke it, called an immediately invoking function expression, which we'll get to in a little bit. Or we could use call and apply. If that's confusing to you, ignore it. An alternative to this is we could just use call. So we could do person.greet.call. And so the difference between bind and call and apply is that call and apply will actually run the function immediately, whereas call will just return a new function so that you can use that whenever you want. So if we knew we just wanted to greet a new person or a new student, we could just do person.greet.call. The first argument is what we want to bind this to be. And so we can give it student. Does it take any arguments? No, it doesn't. It just doesn't. So we can just go ahead and call it like that. So let's comment out the other line where it's called, and you should see hi John printed. And it's no different if we were to use apply here. Any questions on call, this, and bind? Call, apply, bind, and this? It's a little bit, yeah.
So, the difference between apply and bind is that, call and bind is that call is only used like once, while bind used constantly, or can you explain the difference again?
Yeah, so you're onto something where you're saying bind will get used more times, whereas call gets used once. And so call and apply will invoke that the method immediately. So if you know you're going to use it now and only now, you can use call and apply and just run it. But bind will actually return a new function that you can set equal to other things. So like on line 24 here, we did person.greet.bind student, which creates a new function, which is essentially the method of greet, but rather than this.firstname, it's student.firstname, and stores it as a new function. So you can now run that later, you can run it multiple times, you can do whatever you want with it.
So like line 20 and line 24 are kind of doing similar things, or
Line 20 and line 24, yeah, they're doing nearly the same thing in practice, but where it actually differs is that if we were to run line 20, the student object actually has a new method that's part of it, whereas if we were only to run line 24, we only have a new function that we can then run, and it will print out the value of console logging hi this.student. Does that make sense? Yeah.
Can you explain the distinction between call and apply then?
Yeah. So let's do so greet and say so say we're to actually pass a value to greet, and it says what to say. And now we say like something that we're going to say to the person. And so if we want to then call that as person.greet, we would have to do person.greet and send it hi. And then same down here. With person.bind, we do person.bind student, and now that is the greet function that is now bound to student, but it still is expecting one argument. And so if we were to call it like this, student.greet, what would we actually see? Any guesses?
Just a comment down. Like it wouldn't be high.
Very close. What happens if a variable exists but it hasn't been set? Undefined. So because the what to say variable is implicitly declared just because it's expecting it as an argument, it will go ahead and declare that variable for you. But since we didn't actually pass anything in, it's an undefined variable. So we will see undefined, which is, again, an implicit coercion from an undefined value, a primitive type, to a string. So I'll say undefined as a string, concatenate comma space, and concatenate their first name, and they'll say undefined comma John. And so say we wanted to then pass arguments, we could do that in bind. We could say student, bind student, and another argument called hi, and it'll run that with that first argument. Or we could then do person.apply, which will then run it with student with no arguments. Or call with student. And so if you don't pass it any arguments, these two lines are exactly the same. But since we want to pass it arguments, that's where they differ slightly. So apply expects an array as a second argument. And so you would do something like this. And so array index 0 becomes the first argument in the function that's invoked, and like further on with the other array indices. And then with call, you just list them out as parameters like this. And so a good way to remember is A for array, so apply array, and then calls the other one. And so these now are exactly the same. The reason you might want to use apply over call is because, say you don't know how many parameters you're going to pass. You would then create the array in code and then pass that array to apply. So you could do something like var array gets hi, and then pass that array in here, and that will produce the same thing. Cool. Any confusion with setting this manually? It's not something you do all too often. The only time you'll really ever use this is one, if you're doing object orientation, which isn't super common in like web development, especially backend. But you will see it quite a bit when it comes to DOM manipulation. Like if you click a button and you want to assign a function to all the buttons on the page, this will then be bound to the button that was clicked, and so that becomes very useful. And with ES6, which is the newest ECMAScript, came up last year and is still getting rolled out, you have this arrow notation, which is shorthand for a function, so an anonymous function. So whereas in prior versions of JavaScript, the only way to declare an anonymous function was like this. You now see arrow notations, which is just a new notation where it looks like this. It's pretty much shorthand. It's very convenient because it saves a lot of typing. But it actually has a functional difference. It will bind this to where it's lexically scoped rather than where it's invoked. What the heck does that mean? Let's introduce a bug into a program caused by that. So var new person gets first name Jane, greet. Let's do an anonymous function using arrow notation. I'll console log this dot let's say hi, this dot first name. And then say we were to invoke this. What do we expect to see? If this were not arrow notation, what would it say? Hi, Jane, right? Just like the other object. But since this arrow notation will now have things lexically scoped, what is this now scoped to be? So think back, what was lexical scoping? It determines how variables are bound by where they actually sit in your program. And so this function is just sitting in what scope? The global scope? The global. Right? It's here in, it's not within another function, I should say. So if we were like within a function and the function declared new person, then this would then be bound to that function lexically. But since we're in the global execution, this just points to the global variable, global object. Does that make sense? Lexical scoping? Yes, no? I can re-explain it. Yeah, so lexical scoping will determine exactly what variables get bound to where. And so if we had that function print x, which just console logged x, lexical scoping determines what x is. And so if there is a x within the global scope, then it will print that. But say so we now introduce the setX function. What will printx print? Who thinks 42? Who thinks 50? 42 is the answer, right? Because if you think of it just like stack frames, we have that global execution. and then we did var x equals 42, so it creates a variable called x and sets it to be 42. And then we have a function setX, which we actually need to invoke. We call printx, which creates a new stack frame, right? A new execution context that does setX. Says x to be 42. And then we call printx after that finishes running. And so now printx well, now where's the only x? Right here. And so that's lexically scoping, because that's where it sits while you write it. But say we actually wrote the code slightly differently. How about now? What will x print? It will actually still print 42, but lexically it's within 50. So as it's lexically scoped, it would be 50. But I believe this would actually print 42 for some weird reason. It depends where it's invoked. Okay, Vim. Oh, no, it does print this. It prints 50 if it's called within setX. And there's no way to actually access it outside of setX because it's lexically scoped that way. Because when setX finishes executing, printx is actually defined within here. And so when setx is done executing, if we try to actually call it outside, it won't work because it's now no longer within scope. And that's because JavaScript is lexically scoped that is true. And so if we now look at this example up on line 33, when I say this is now lexically scoped, this sits where in the program? Is it within another function like printx is? No, right? It's within the global scope. Therefore, this now refers to the global object, no matter how we call it. So if we did newPerson.greet, that will say what? High undefined, right? Because this now refers to the global object. And is there a first name property on the global object? No, right? We never defined one. And so it'll just say undefined. Yeah.
Why doesn't this refer to the new person object? Or is it not?
It's specifically because of this weird arrow notation.
That's just how it works.
Yeah, the way it works is it will lexically scope this rather than setting it to the invoker like it would traditionally. What happens if we then try to do newPerson.greet.bind or call or bind or whichever one, new person? We would expect that to also print out hi Jane, but it says hi undefined both times because arrow functions will bind to how they're lexically scoped and will not budge no matter how you try to affect it manually. So be wary of that once we get into, it's possible to introduce a bug using the arrow notation while using MongoDB, which we'll get into, and so I'll just talk about it early so it doesn't arise then. Alrighty. So first class functions. What the heck are first class functions? Has anybody heard this term before? So first-class functions means that functions are first-class citizens, meaning they can be treated in every single way that a normal variable would be treated. And so this is often something that happens with functional languages. And JavaScript is kind of this weird child of a functional and like an object-oriented language. And so we have aspects of object orientation, like the prototype inheritance, and also aspects of functional programming, like first-class functions. And so it means that functions are treated in the same way as objects, because as we discussed before, they are objects, which means they can be assigned to variables, like we showed, like var x equals an anonymous function. An anonymous function, if I haven't talked about it before, is just a function without a name. They can be assigned to array values. They can be assigned to object values, pretty much anywhere you want. And they can be passed as arguments to other functions, just like objects would. And additionally, they can be returned from functions, just like an object would be returned. And so why might that be helpful? Can anybody think of a reason we might use this? We'll see. So it allows for the creation of higher order functions, which is just a function that takes any number of functions as input or returns a function. And so some examples of these are map, filter, and reduce. Has anybody heard of these three functions before? Maybe a little bit. If you take CS51, you'll dive into OCaml, which is a functional language, and these will become your best friends. So if you're thinking about that, pay attention now, because you'll have a head start with your pset buddies. But let's look at what map, filter, and reduce do. So map, so MDN, Mozilla Developer Network, is a great resource if you ever want to look anything up. They write tutorials, they write great documentation. And so here's array.prototype.map. And so we see array.prototype.map, and that means what? What's array.prototype mean?
Exists for every array.
Yeah. Is part of that array prototype that we talked about here. So that means every single instance of an array that we ever create, we have access to this map function. With the asterisk, of course, because this function was introduced in ES6, which means you don't necessarily have support for all browsers yet. But what it does, it allows you to take a function and execute that function on every single part of an array. So say we have a function, so var x equal, or array 0, 1, 2, 3. And so x is now an array. And say we wanted to run a function on every single one of the array. We could write a for loop and do that, or we could use this higher order function. And so map, if we do x.map, we see that it's a function, and it takes a function as an argument, which means it's a higher order function. And what does it do? It creates a new array with the results of calling a provided function on every single element in the array. What? Can anybody translate that into understandable English? Yeah.
Just like do a function that executes a function every element.
Yeah, it just runs a function on each value, right? And so if we have 1, 0, 1, 2, 3, say we wanted to change this to 1, 2, 3, 4. So what function would we run on every single one of those? X plus 1, right? So we could do x.map and actually pass into a function. So let's actually declare a new function. So call it function add 1. It takes x as an argument, and it returns what? X plus 1. And so now we can run add 1 on anything. 1, and it will give you 2. And so say we wanted to run x.map, just pass add 1 in, and we get 1, 2, 3, 4. And so this is a quick way to run a function on every single value in an array. So why might we use this? Yeah, exactly. So say we wanted to affect all of the markers somehow, like change their color or something, and that was a function that we could write. We could just have an array of all the markers, pass that function in, and it'll run that on every single marker. Or say you're a teacher of a class and you wanted to compute a curve and then apply that curve to each person. Rather than plugging and chugging manually, you just pass that function in and it'll run it on all of the scores. And so this is a very basic example, and it'll come in handy once you start working with lots of data. And so we also have filter, which will take an array and give you anything that passes a certain function, meaning array filter. So again, it's array.prototype.filter, which means it's available to every single array object. We can do it's big enough value. Say return value is greater than or equal to 10. And what that does is it filters an array and returns anything that passes true. So you give it a function. The function will return a Boolean. And if the array element returns true with that function, then it will be included in that final array. Otherwise, it won't be. So say we have var x equals this. So x is our same array, and we wanted to keep all of the even numbers. We could write a function that declares if something is even, and then pass that into array.filter. So x.filter, and that's just using an anonymous function now. That takes one parameter and returns whether it's even or not. Which, how do we see if something's even? Yeah, so modulo 2, and make sure that's equal to 0. And we have all of the even numbers. Yeah.
So why does it go back to like, the original after? Like,
So if we do x, it still has the original.
yeah.
Because it creates a new array with the elements and passes that back to you.
Okay. Does it store it anywhere, or is it just?
Not unless we tell it to. So if we did that filter function and said var x filtered equals that, then now we have x is unchanged and x filtered is those. And so lastly, we have reducing. Which is my favorite one. And it'll apply a function against an accumulator and each value of the array from left to right and reduce it to a single value. What does that mean? It essentially flattens an array based on a function that you give it. So let's look at that in practice. So say we had x is 0, 1, 2, 3, and say we wanted to add them all up. We could do that manually, or we can just pass it a function. And so let's do function that takes 2 parameters. So accumulate. That takes new value, or let's see, previous total and new value. And it returns the previous total and the new value. Oh, what? Good one, Jordan. I said returns and typed it as well. Okay. And so that's now accumulating function. It's the same as our sum function, but we changed the name of the arguments just for more clarity as to what this function actually does. And so now let's pass in x dot reduce and then pass it accumulate. And it also expects what you want it to start from. Because say you're concatenating from a string, you don't know what the base empty string is. So maybe it should be empty string, maybe it should be something else. And so it allows you to pass it optional starting value. And so since we're accumulating everything, what is our starting value? 0. And so if we pass that in, it'll sum it for us. And so this is very, very handy for a lot of reasons, like summing a bunch in an array or folding it. Folding is the term that you use in OCaml, so if you're taking CS50, you can show off to your friends. But it'll fold it based on some function that you pass. All right, you'll get some practice with this later. And so synchronous versus async, single-threaded, multi-threaded. You may have heard these terms thrown around. Does anybody know which of these terms describes JavaScript? All of them. So JavaScript is single-threaded and it's synchronous, but it also has asynchronous functions as well. But since it's single-threaded and synchronous, it means that if you have a function that takes a really long time, it'll actually block everything else from running. So like in C, if we did something like getInt and you never gave an int, what happens to the rest of the program? It's just kind of sitting there waiting for you to do something, right? And so JavaScript is also single-threaded, which means it doesn't have other processes going on at a single time. And it's synchronous, meaning it can't move on until something's done. So if you have a very long executing function, then it kind of blocks everything else. And so let's look at that in practice. Let's use my slides. So we can just run JavaScript in every page using our console. So let's write this function called hang, which takes seconds in. And what it does is it'll create now as a new date. And so that essentially just gets the current time. We can actually just what happened here? Block scripts execution in. Okay, the page is blocking because. Okay, so if we just ran new date, it gets us a new date. And if we ran new date.getTime, it'll get us like the time in milliseconds since some date in 1970, which is rather arbitrary, but that's how all computers tell time, by the way. They count milliseconds from some day in 1970. But let's write this function called hang. That takes seconds. And it does new time. And while a new date get time is less than now plus some sort of seconds that we determine times 1,000 because they're milliseconds. Do nothing. While this, do nothing. Syntax errors galore. Okay. While that, do nothing. What? While what now? Plus time in seconds. That seems right. Okay. So that's our function hang. And then if we run hang for, let's call it 10 seconds, it's now running. And now I can't do anything. Right? I'm trying to click on my slides, but it's running for now. Okay. So because JavaScript is single-threaded and synchronous, while hanging was running, and all it does is saying, oh, is now after now was plus 10 seconds? No. Okay. How about now? How about now? How about now? And keeps running that, right? It's a while loop that doesn't actually do anything. And while that runs, it's taking up the only thread that JavaScript has. And so my page becomes unresponsive. And so that is not a good thing. So say every single function that you ever write takes a second or two to run, and then you run them. What's the user going to say? Man, what a crappy website, right? You can't do anything. And so because of that, because of that, JavaScript has functions that act asynchronously. And so let's talk about asynchronous JavaScript. So you may have heard these terms thrown around: execution stack, browser APIs, function queue, event loop. But the way they're used is really powerful in terms of getting things done without blocking the user. And so we've all heard the term execution stack. And that essentially determines in what order these things are going to run, right? So if you have a bunch of functions up on the stack, it'll run them, then pop it off, and then wait for the next function in the script. And then if it sees another function in the script, it'll just pop it up here and just keep running it. But we also have these things called browser APIs. And if you notice within that window object, we have a bunch of functions here that don't necessarily appear within Node. And that's because those are part of the browser APIs. But there are some API functions that appear both in the window object and in the global object. And those include set timeout, set interval, and maybe like fetch or like Ajax calls and stuff like that. And then we also have what's called the function queue. And what's called an event loop. And so these are all the actual technical terms, and they work as so. So global execution is whatever JavaScript is running. And so if things are running, they'll get popped onto the stack, and then they'll run synchronously until you're done. But if we call one of these browser APIs, then it'll run separately from here. And so say we wanted to grab a page and display it. If we were to do that synchronously, then the user's stuck while the page is loading. And that's definitely no good. And so what did we use in CS50 to get around that? How do we make asynchronous requests?
Ajax?
Yeah, using Ajax, asynchronous JavaScript and XML. And so that allows you to go grab a page. So let's call that Ajax. And then what do we pass Ajax? We passed it a config file which tells you like where you're getting stuff from, and then we also passed it some sort of function. What do we call that? A callback function? Yeah. So callback functions, we'll talk about them in a little bit, but they essentially determine what you're going to do after this is done. And so we also have other things called set timeout, set interval, and these are all part of the browser APIs. And so set timeout means run this code after some sort of milliseconds. Set interval means run this code every number of milliseconds. And Ajax is just making a network request. And so it would be annoying if you wanted to set something for a delay of 1 second, but it actually blocked everything else for that 1 second, right? And so that's why there's this thing called a browser API. And the browser API will actually take care of that timeout for you. Meaning if you set timeout some sort of console log for a second, it will wait that second, and then it'll say, hey, that second is over. Let's put that callback function onto the function queue. And then all your code is still running here, rather asynchronously, right? This is running while this is also running and doing other things. And so that's why JavaScript becomes asynchronous in nature. And as soon as this is done, it says, hey, now we're ready to run this function. Let's throw this on the function queue. And so the function queue will start to queue up a bunch of functions that are ready to run. And so when the Ajax call comes back, maybe that callback is also ready to run. Say there is an onClick attribute of a button that you clicked, and maybe that got thrown over here too. And so when do these actually get run by the browser? the event loop takes care of that. And so as soon as this stack is cleared, then it says, hey, I'm ready to do something else. Give me something. And the event loop says, hey, we have this function queued up. So let's put this up onto the stack. It'll run, it'll be done running, and then that'll call the callback and throw that up here. But maybe there's other JavaScript that was running in the meantime, so it says, hey, hold off for a second, run this code, and once this is clear, only then does the callback get loaded up in here. Yeah?
So the execution stack is what's running like behind the scenes of the global execution. Like, what is it? You said that we have these kind of two compartments in order for like what's on the page not to be disturbed by what's running behind the scenes, right?
Yeah.
So like, is the execution stack the thing that's happening behind the scenes?
The browser APIs are happening behind the scenes on the browser, but the execution stack is whatever script you wrote. So let's look at an example. I think that would help. So let's do a function called print1, and all it does is console.log1. So we have three functions. Each takes 0 arguments, and we'll print out 1, 2, and 3 respectively. And say we wanted to then call these functions. So one will do set timeout of print1 for 1 second. The other, let's do set timeout print2 for 0 seconds, and set timeout, actually let's just call print3. So what do we think is going to happen here? Yeah.
Print 1, wait a second, and print 2 and print 3.
So that would be if it was fully synchronous. So if it was fully synchronous and all we had was the execution stack, it would say set timeout print1, and it'll say, okay, wait 1 second, then it'll print 1. Then it'll say, okay, set timeout print2 of 0 seconds. All right, 0 seconds is done, print 2. And it'll say, hey, now let's print 3, and it'll print 1, 2, 3. But that's not how the JavaScript engine works. Rather, we have these asynchronicities. I don't know if that's a word, but we have this asynchronous nature. So it sees set timeout. So the global execution is this script. And so first it goes and creates those functions, and it says set timeout print1 1000. And says, hey, that's a set timeout call. I'm going to do it, but by doing it, you're actually running the API. So just like in CS50s, you would make calls to like the Google Maps API. Right now, we're making a call to the browser API or the Node.js C++ API. And so that's actually this API call. And it goes and says, all right, set timeout, print 1 of 1000 seconds. All right, this is now clear. What's the next line of code? Set timeout, print 2 of 0. So that's the browser API. All right, now what's the next call? Just print 3. And so that's a new frame. And then it will console.log 3. Just because these things happen so fast that these, actually there's no way that these will beat this one, because it runs it in synchronous order, so it calls set timeout print 3, and these get dispatched over to the API. And then print 3 will immediately print 3. And then what happens after 0 seconds? Print 2 is now ready to be run, and so that gets thrown up onto the function queue. And so that over here is print 2. And then as soon as print 3 is done running, so maybe the set timeout of 0 was done before print 3 got executed, but since this stack wasn't clear, this never got called. And so as soon as print 3 is done running, now it says, all right, our execution stack is empty. let's pull something from the function queue. What's there? Print 2 is. So this gets called. It prints out 2, and then that stack frame is done. And that all happens within like the blink of an eye. And so this is done. And then now the computer's like, all right, there's nothing happening. I'm just going to wait for input. And then after 1 second, the browser API says, hey, this is now ready to queue. It'll throw print 1 onto the function queue. The event loop says, hey, execution stack's empty. Let's pull something from the function queue. Print 1 appears, and then 1 second later, it prints 1. Yeah?
Is it true that print 1 will appear on the stack queue last, on the function queue last, even though it's declared before print 2? So what I thought it would have, what I thought would happen would, is print 1 would go on the function queue, and then it would go onto the event loop after the 3 has been printed, and then it would then run, wait 1 second, and then the print 2 would go onto the function queue, the event loop would throw it onto the global execution stack, and then it would do 3, 2, 1 that way. But print 1 doesn't end up on the function queue last. That's what I thought of it.
So it actually does. So there's 3 different staging areas where functions are ready to run. And so there's the actual execution stack, which is for all the synchronous functions. There's a browser API where the browser, you kind of dispatch off to the browser to do with whatever the spec is. And then there's also the function queue, which is where other functions go. After the browser API is done with them, it dispatches them over to here. And so these 2 set timeout calls are actually happening at the same time. And so their counter is actually going down at the same time. And so since set timeout of P2 finishes before the set timeout of print P1, that gets thrown onto the function queue first. And if it's possible that if set timeout were that hang call that I wrote, and that it hung for like 10 seconds, then P1 wouldn't get run until 10 seconds later. So this is more of like a wait at least 1 second before running, because it's wait 1 second before queuing it up, and then run it as soon as everything else is done. So if P2 over here ended up taking forever to run, then P1 wouldn't get to run until after P2 is finished.
So P2 is guaranteed to run before P1 no matter what?
Yes.
Okay.
Because there's only one function queue. At least I can't think of any reason why P2 or P1 would run before P2. But maybe it's possible. So say P3 took like 10 minutes to run. I think, oh yeah, so even if P3 took 10 seconds to run, this would be on the function queue waiting anyway. Okay. Yeah. And so let's see if Jordan's ramblings were correct. Cool. Do you see that 1 second delay? So it instantly prints 3 and 2, and then 1 second later we'll print out P1. And so what would happen if rather than queuing this up, we actually just ran print 2? What would this now print out? Yeah, 2, 3, wait a second, then 1. What if this happened? Oops, this should be 3. What would then print out? Yep. Cool. Any questions on this control flow? Yeah.
If there's like another function that's like kind of unrelated that's also running the execution stack, then how does it prioritize between those functions and the ones in the function queue? Does it like alternate, or is it just like finish all those first and then?
Yep, so it always finishes the execution stack in its entirety before looking into the function queue. So say we had that hang function here, what would print in this case? Yeah, so 1, it would wait 10 seconds, print 2, and then look into the function queue for 2 and 3, and then 1. But the 2, 3, and 1 at the end would happen instantaneously because they had already been queued up for like 9 or so seconds. I can't run this because I don't have the hang function here, but take my word on it. Yeah.
In terms of like the order of these like 3 stations,
Mm-hmm.
so in terms of when the code runs, because P3 goes in immediately,
Mm-hmm.
like so the first thing is execution stack,
Mm-hmm.
and then the other 2 go to the browser APIs.
Yep.
And then they go to the queue, and then the execution stack after that. So like P3 never actually goes into the function queue.
Correct. Yeah. So it never gets dispatched to the browser API. So it just runs.
Okay. So like the browser API is like an alternate route that you have to define. Like
You don't have to.
as in, like,
Yeah, you have to make API calls to access it, but yeah,
Okay.
it's like an alternate
Yeah.
thing. Yeah. Huh?
Will the set timeouts get added to the API at once, or like when they come in the code?
When they come in the code, because the execution stack is actually what's throwing them over here.
Okay, because then wouldn't there feasibly be a problem if these are like far apart in the code? So then the counter for the first one is like can beat the counter of the second one.
Oh,
So
race
there's, like,
condition.
yeah.
Yep.
So then like isn't this bad if this could feasibly print out like 312 in like some situations?
Yes. So it creates what's called a race condition. So if this, if these 2 set timeouts, if this was put on more than a second after this one, this would then print out first.
Okay.
And that's called a race condition. Race conditions are like the bane of a lot of people's existence because, like, say there was a race condition when you're working with your ATM, and maybe like your balance drops negative. It's like, oh, you shouldn't have a negative balance, so it makes it 0, and then you put money into it. Then you now have infinite money, right? And so race conditions are like definitely something you always have to watch out for, and there's a way to make asynchronous calls work in a certain order. And the way to do that, yeah, you fix that by using what are called callbacks. And so callbacks allow you to control flow within asynchronous calls because you don't necessarily know exactly what order asynchronous calls are going to return in. So say you use an AJAX function to go grab a bunch of different URLs. You have no idea which one's going to come back first. And so you need to control the flow of the application. So control what you want to happen when each of these things return. And so some examples of those asynchronous calls, we talked about set timeout. There's something called XML HTTP request, which is the very low-level browser call for making network requests. jQuery's AJAX uses that in order to allow you to make asynchronous calls without touching that really annoying XHR request. And then you have this new thing called fetch, which is now native in almost every browser that allows you to make AJAX calls without loading the entirety of the jQuery library. So we'll be using fetch quite a bit in a bit. But callbacks, what they do is you pass it a function, and the function will run once the asynchronous call returns a value. And so just like we queued up this, P1 is actually a callback. And so this is the function that runs after this returns. And so since set timeout doesn't do anything other than wait, then the callback is really just running after some seconds. But you can actually pass values into the callback. So say, like in CS50, when you made AJAX calls, the callback that you provided actually did something with the result, right? So when you did like CS50, the news one, I forget what the piece that's called, but you made a network request to Google's news, right? And then it returns a bunch of articles. And then you said in the callback, use these articles and populate your little window that comes up. And so that was actually a callback that did something with the values. And so that's what we use in order to control asynchronous call flow. And so let's look at Oh, and so that allows you to not halt and wait for value. It allows you to run code in the execution stack while you're waiting on a return value from like a fetch call or something like that. So let's actually look at what callbacks are. So another reason you'd use a callback is if you're making a database query, which may not return instantaneously. Like if you have a huge database, it might take a few fractions of a second, which is forever in like JavaScript's life. So say we have this function called get users from the database, and it takes a callback. And so this is meant to simulate fetching data from a database. And what it does is it does a set timeout of, I'm just going to write a function. So I use the squiggle notation here. But essentially what you're doing is you're queuing up something that returns this object, first name Jordan, last name Hayashi, after 1 second. If you don't understand the cryptic code, no worries. But that's what it does. And so that's just meant to simulate grabbing a user from a database. And so if you notice, what it does is after it grabs the first name, the user object, it actually runs the callback and passes that object into the callback as its parameter. And so when we call that, let's do, and so let's write a function that will query database for a user, then greet the user. So if we were doing this synchronously, what would we do? We would do something like var user get users synchronously, and then do like console log user or hi user's first name. So we didn't do get user synchronous, the function, but this is what it would look like if it existed. So essentially you create this new user variable and then call get user synchronous, which is a function that will query the database and return a user. And then you console log hi user's first name. So what's the problem with this code? Yeah.
It takes a while. I mean, it could take forever.
Yeah, so what happens if the database crashes? Then it's sitting at line 8 waiting for that to return, and it's not going to set that variable equal to user until that happens. And so what happens for the next function that's on the stack, or everything that's on the function queue? They just kind of hang there forever. And so this is bad practice. And that's why, especially with network requests, when you're not guaranteed to have a response immediately, that's why we use asynchronous calls. And so if you notice, get users from database is an asynchronous call, and so it takes a callback. And so it allows us to pass it a callback and say, hey, whenever you're done, take your time, but not really, but take your time and return the value, and then run this function using that value. And so I'm going to go ahead and do other stuff while you do that, but whenever you're done, just let me know. And how do you let me know? By throwing it up on the function queue. So let's now do this in an asynchronous manner. So first of all, we got to make the network call, right? So get users from database. And what does it take as a parameter? A callback. Callback what? A callback function. So we actually pass it a function. So we can go ahead and do function something. And so what is the function expecting as an argument? If we look at how it's called here, what is eventually getting passed to the user? The callback function. The what?
Like first name, last name.
Yeah, an object that defines the user, right? So the callback function should expect some sort of user object. And then what do we want to do with that user object? Just say hi, right? Say hi, user object dot first name. So even though that user object doesn't exist yet, we're going to go ahead and say, hey, we know what you're going to use me for. You're going to pass me a user that you grabbed from the database. And so since I know that I'm eventually going to get that user as a parameter, I'm just going to go ahead and use that. And so this function here is an anonymous function that takes a user object and just console logs, hi, the user object's first name. And that's all that callback is. And so what happens if we run this code? Any guesses? No? No guesses at all? I'm just going to run it. Uh-oh, of course. Now I'm going to run it. One. Oh, no. Oh, duh. Going to invoke the function. All right, so did you see that 1 second delay? So now it's actually actively fetching, and then once it gets the value back, it throws that callback on the function queue, and then runs it. So do you want to go through the flow on the board? Would that help? Yeah, all right, let's do this. So, all right. So we have first our get users from database, and that's just our own API call that we wrote, which goes and grabs a first name. So let's pretend that's an AJAX call. And then we also have a get user call, a greet user, and that's the function that we immediately invoke. So we invoke greet user. And what does that do? What's the first thing that greet user does? Yeah, it calls get users from database. Does it go on the execution stack? It actually first goes on here, so it does get users. And what's the first thing that get user does? Yeah, it makes a browser API call, and so it does that. It says set timeout, or we're going to pretend it's an AJAX call. And its parameters are what? A callback function is anonymous callback, and some delay. And then what? What happens next? What line did we just run? Yeah, we just finished line 3, right? And so line 4 is what? Because it's synchronous, right? It goes, line 3 is done, because now my execution stack is done. It ran the set timeout call. And now what happens? That function's done, right? So we pop it off the stack. So now what's next? We're within greet user still, right? And so greet user was which line? Well, which line did we already run? We ran lines 8 through 10, right? That's all effectively one line in JavaScript. And so what's the next line? 11, which does what? Yeah, it says greet user is now done. We're done with that. And that all happened within like a millisecond. And now what? What happens the very next millisecond? Not the next millisecond. Yeah, essentially this. And then this guy's still like, oh, I'm waiting. A few 100 milliseconds later, this guy's still waiting. And then what happens 999 milliseconds later? Yeah, so that set timeout, that says, all right, we're now ready to do this. And it's saying, hey, I got our value back from the database. I'm ready to run whenever. At your convenience, meaning as soon as you have nothing else to do, run me. So this is now here. And this is now done. So now what happens? Yeah, the event loop says, hey, there's nothing here. Let me check the function queue. So the event loop actually checks the function queue every single millisecond or every single cycle. But there's nothing to do, so it kind of just did nothing. And now it sees something. It says, all right, let's toss this callback onto the call stack. Just an anonymous callback. So it's effectively just an anonymous function on the stack. And what does it do? Yeah, so it runs console.log hi user object. And what user object do we pass to it? Yeah, the user object, right? First name Jordan, last name Hayashi. And so it runs console log hi, comma, user object dot first name, outputs hi Jordan. Then what? Then pops off the stack, and we're effectively done. There's nothing left to do. And so that was the flow of that application. Does that make sense? Yeah.
So callback is defined in the first function. How does it, where is it referenced in the second function? It knows the word callback.
Yeah, so when we do stuff like this, we have a function called add1, right? And it takes a single parameter, and all it does is takes that parameter and adds 1 to it. And so x, we could name anything, because all it is saying, hey, just remember, use this name for just as a reference to my very first parameter, but it doesn't matter what you actually name it, because all you're doing is taking that first parameter and adding 1 to it. And so if we wanted to use this function, how do we use it? Yeah, we just pass in anything, right? Add 112. And what does that do? It says, hey, it's effectively saying we do x equals 12, and then return x plus 1, right? And so it's the same thing up here, but rather than using a number for the parameter, we're actually using a function. And so there's no difference between adding 1 and doing say get users and passing it a callback function. So function. And then immediately just running function name on some user. Right, so this is not really any different than the previous example with add1. What you're doing is you're passing in a function name, and then you're immediately calling that function name on this hard-coded example. And so what happens if we pass it something like this? What do we expect to see? Who thinks it'll work? Who thinks it'll yell at me? Who's undecided? All right, so let's check it out. Function name is not a function because we just tried to invoke. We essentially did this. Right. And it's like, hey, one's a number, it's not a function. We can't call it like it's a function. And so since functions are first-class citizens and they're just objects, we can actually just pass them as a parameter to a function. And so that's what we did up here. Even though it looks a little more cryptic, we're passing get users from database a callback, and they're just saying whoever wrote this database call presumably has an API that says, hey, I take a callback as a parameter, and the callback should take one parameter. That one parameter is the user object that's returned. And so we write a callback based on that spec. And so we could actually say function greet user from, oh, we already called that, say hi to user. That takes a single object. And what does it do? It just says console.log hi to the object's first name. So now we have a new function called say hi to an object. It takes an object as a parameter and then immediately says console.log the object's first name prepended with hi. And so rather than using an anonymous function here, we can actually just do this. And we're passing that get users function that we, not get users, say hi to object. Right, because that function fits exactly what the callback should. The callback is passed an object that has some first name as a parameter, and then you can do with it whatever you want. And so say hi to object accepts an object with a first name parameter and then invokes console log object's first name. And so since functions are first class citizens, we can pass say hi to object to get users from database. And essentially what that does, as soon as this is done, it says callback with this object, which essentially just runs say hi to object with this object. And it doesn't even matter what the other part of the object is because we ignore it. And then we just console log whatever. Right? Does that make sense? Do callbacks make sense to everybody? Yeah.
Sorry, can you explain why this fixes the problem again? That they're asynchronous and that the database might never return or something?
Yeah, so all right, this is get users. So it's funny, this will error and then 1 second later print out hi. Let me see. Get users. So I think this will actually error and then say hi 1 second later. Oh, just kidding. If there was no syntax error, I don't want to fix it, but the reason that it fixes the error. So what happens if the database never returns? Nothing, but not nothing in a bad way, nothing in a good way. If we had done this synchronously and the database never returned, this would indefinitely be on the stack, right? Get users. Right, because this function call is actually waiting for the response. And so you can't do anything. Whereas in this callback example, get users is actually waiting over here. And so that means everything else is free to run. You can use the website. It just won't greet you, which isn't really the end of the world. And as far as database crashing, this is like the least of your concerns. And so like it doesn't really affect the user in a huge way, and it just silently fails. It'll just sit there hanging in the background, but it's not clogging up your only resource. And so that's why callbacks are good. It doesn't actually block. So JavaScript is non-blocking because of this. Does that answer your question? Cool. Any other questions about callbacks? Yeah.
Can you give us, just for interest, like a more low-level picture of like where the browser APIs are running, and just like so it makes more sense? Or I can ask after too.
Yeah, I will in a little bit because I'm going to try to jam some stuff in here real quick. So let's look at how we might actually use a callback in real life. So this is a function that I actually wrote for something we'll take a look at later tomorrow. And it's an actual function that logs in a user. And if you see, there's a lot of callbacks in play here. So we have function, which is, we have login, which is a function that takes 3 parameters, a request, a response, and a callback. I'll talk about this more in depth later because it's express. But essentially, you receive a request, you send a response, and you have a callback to run later if there's an error or if you want to pass the control flow to something else. But first of all, we see user find one, which queries the database. So it finds a user whose email is in the request body. Might be confusing, but it takes the second parameter, which is a callback. The callback is a function that takes an error in a user. And if there's an error, then you return the callback of the original function and that error. If not, then you continue. And you do what you do, you grab that user that you grabbed and compare its password against the hash. And so you pass the password that from the request, and you compare that with this method on the user compare password. And it'll return a callback function that is either error or, and then a Boolean that's whether the password is a match or not. I meant to replace that with the non-arrow notation, but if there's an error here, you return the original callback with an error. Else you say, hey, was it a match with the password? If not, return a 401 status, which means unauthorized, incorrect password. If it was the correct password, then let's go ahead and create a token for them. So the payloads, their user ID, their email, and a company name, which is not relevant. And you go ahead and create a user token, which is this jot.sign, and you pass it the payload, which it encodes into the token, a secret, which is the hash that you create, a confident object, and another callback, if there's which takes an error and the token that this will eventually return, right? Because user.find1 will eventually return a user, and so that's the second parameter in the callback. User.comparePassword will eventually pass back its match, which is whether the password matched or not, which is the second thing of a callback. JotSign will pass an error and a token. If the token's good, it'll pass back a token. If not, it'll pass back an error. So do you start to see a pattern here? You want these all to run in a specific order. Like you don't want to check the password before you get the user. And so you can't write that synchronously. And you can't write a token until you know that their password is correct. So you have to do this in a callback way so that you're guaranteed that this goes first, then this, then this, then this. But it's a little bit annoying because you get what's called callback hell, or the pyramid of doom, or a cow's head, some people call it, or the Christmas tree, where you start to see this sort of thing, right? So say you had like 100 things in a row. You're going to be like writing code over here, which is stylistically good, right? Or is it? And so that's where you fall into this thing. Callback hell is actually a technical term. And so you have a callback after callback after callback. But this used to be the only way that you could do this. And it's a little annoying because like line 4, line 7, line 20, line 24 are all the exact same line of code. But since each callback will pass back a different error, you have to check it immediately. So this works perfectly. It'll return your token if it works. Otherwise, it'll fail with incorrect password or with any other of these errors. But that's what backend coding looks like with callbacks. Let me show you a quick example of how you could do things otherwise. And that's with promises, which were introduced in ES6. And it alleviates this callback hell. How? It allows you to write code that assumes a value is returned with a success function. And so you essentially define a success function that says, hey, I'm just going to assume that I have this value to use, and I'm going to use it. And then you only need a single error handler, because if any of the promises fail, it'll return to the very bottommost error handler. And what does that look like? This. So this is the exact same code. We can even compare it side to side. Notice how the auth function starts wrapping because the lines get too long, but the promise one is fine. And so you see a bunch of .thens, .then, .then, and that means assume that the previous request worked, and then go ahead and use the value. So you see user.find1, which is the same thing as user.find1 over there, and .exec turns it into a callback, or a promise rather than having to pass a callback. And you see .then with a function that only takes a user and not an error. So that's the exact same thing. You can compare lines 3 through 5 with lines 3 through 6 over there. And all it's saying is, hey, grab a user, and whenever it returns, take that user and compare its password. And if you notice over here, compare password takes a callback with the error and match. But here we just say, hey, just return that and assume that it is a match. If it's an error, we'll worry about that later. And then check if it's a match. If it is, if it's not, send an incorrect password, create the payload just like we did, and then return jot.sign, which is another asynchronous call, which is a promise. And then assume that it doesn't error and passes back a token. If the token is good, then give it to the user, and then save that user, which is the same code over here, which only takes an error as a callback. So then we go ahead and just say, then return the token. But what about all of the error handling? That's all handled by this line down here, which is just one catch. So if any of these promises fail, it gets caught by this error handler, which takes the function and returns next error, which should be callback error. So this should be callback. But this is now like the cool, trendy way to do it rather than doing it with callbacks, just because it's neater code, a lot easier to read, and more succinct. And we can dive into promises a little bit later, but we're running a little bit short on time. But any questions about this? We'll look into it a lot deeper once we get to coding this example, which we will do. So no worries if it looks like gibberish now, because in a few days you'll be like, oh, I'm actually going to write this for myself. And one last thing I wanted to touch on was closures, which is also the hardest part, but I guess we'll cover that after lunch. So we can do lunch now and then be back around 2 and we'll cover closures.